Hi everybody, welcome to podcast 2.02 and get ready to actually learn to name something. Ionic compounds are by far the most common type of thing that we name, so we're going to learn the different types, different charged ions, where you have to use Roman numerals to figure out the charges, like our copper 2 is Cu plus 2. So remembering that we've got some Roman numerals we have to use. We've got the same charge, when to reduce, when not to reduce, and lastly our polyatomic ions. So let's hop right into it. Binary ionic compounds. A metal and a non-metal. So again, it's ionic, so you're going to start with a metal and a non-metal. Write the ions, and crisscross makes you wanna, you may not know what I'm talking about, but hold on. So hopefully you get to hear that crisscross makes you wanna jump, jump. The daddy Mac will make you jump, jump. So what am I talking about with this? If you can actually handle dealing with the crisscross music in the background, which was, of course, what I used to bebop to back in the day and wear my clothes backwards just like crisscross does. But what I would mean with something like this is you learned in the last podcast, for example, that magnesium has a +2 charge, which is wiggada 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 whack, and chloride would have a -1 charge. So when we crisscross, it makes you want to jump, jump, and what happens here is you get Mg1Cl2. So I'm going to stop crisscross now, sadly. But don't worry, it'll come back. And the reason why we do this is to balance the charges. So if magnesium is +2, and I know that compounds have an even charge, one chlorine, the sum of these two would still be +1, so I need another chlorine to make the charge 0. So crisscrossing is just a faster way of counting what you have to do to figure these out. So let's do some examples. Sodium chloride. Sodium is Na. Periodic table tells me Na is +1. Chloride is Cl. Periodic table tells me that's -1. Crisscross these, and because they're the same charge, it's just NaCl. Aluminum chloride. Periodic table tells me aluminum's in the +3 column. Chloride's in the -1 column. Crisscross, Al3, I did that wrong. AlCl3. And again, remember, the signs don't move, just the numbers. Sodium sulfide. Na +1, S -2, Na2S. The 2 comes down, the 1 comes down. Again, this is not Na -2S. That would be bad. Iron 2 hydroxide. Iron 2 is a Roman metal. It's got the Roman numeral here. So iron 2 hydroxide. So that tells me that iron, which has a couple of different choices for charge, is +2. Hydroxide is a polyatomic ion we've memorized, which is -1. So crisscross that, and here's something a little different. I'm not going to have 2 H's. I have 2 hydroxides. So the way I show that is FeOH in parentheses 2. Again, I don't have 2 hydrogens, I have 2 hydroxides. You need to think of your polyatomic units like a hand. You think of your hand as a unit. You never think of them as individual parts, right? You think of your hand as punching something, picking something up. You don't go, oh, you know what, my pinky doesn't really do much when I pick something up. No, your hand is a unit, and you need to think of these polyatomic ions as a unit. You can never separate them. You can't do anything, you know, if I said clap your hands, you don't think of one hand with 10 fingers. You think of 2 hands with 5, whatever. You get the idea. Cobalt 2, CO, +2, oxide, O, -2. Now if I crisscross here, I'm going to get CO2, O2. And this, really, the point of crisscrossing is to balance the charges. Looking at this right now, the charges are balanced. So the best and only correct answer is Q, not Q2U2. So hopefully that helps. Going the other way. If I give you the names and give you the formulas and try and give me the names. So Fe is iron. My first question is iron a metal? So I look on the periodic table to make sure I can name it using my crisscrossing rules. Iron is on the left of the stair step, so it is a metal. Is it a Roman metal? Is it at the region of the periodic table that needs a Roman numeral? The answer to that is yes. So I put parentheses that are empty right now. Then I have oxygen. Oxygen is a nonmetal, but I know since the first one's a metal, I have to make it a negative ion. So to make one element a negative ion, you need to make it end in "ide" and sound good. If you don't know what I mean, you're not going to say oxygenide. That doesn't sound good. You're going to say oxide. You're not going to say, I don't even know what else you can do with that one. But fluorine, fluoride. Oh, sounds good. Chlorine becomes chloride. And again, if it ends in "ide," I think anything that ends in "ide" is an evil name. So you know that it's going to have a negative charge. So now I have to figure out what the charges are for these things. So what I'm going to do is uncrisscross, which makes you want to jump. So looking at this uncrisscross, oxide must be -2. The periodic table says that it is. And iron must be +3. So iron with a +3 charge is iron 3. CrO2, look for chromium. It is a metal. It is a Roman metal. Again, oxygen is oxide. Now here, when I uncrisscross this, it says chromium is +2 and oxygen is -1, but the periodic table, which is always right, tells me that oxygen should be -2. So in order to have that 2 there in CrO2, I need to have Cr +4, O -2. When I crisscross this, I get Cr2O4, which I should then reduce, because remember they're ionic compounds, we give the most reduced forms, to CrO2. So this means, and this is as hard as it gets, this should be chromium 4, unless you know numerals, and knowing that IV is 4 is hard. Alright, is calcium a metal? Yes, of course it is. Whoops, I wrote Cr oxide. Cr should be chromium. Sorry about that. And you thought you were going to get a mistake point on the pod quiz. Ca is calcium. It's a metal, not a Roman metal, so I do not use a Roman numeral. Cl is chlorine, but to make it sound evil, it is chloride. Yay. Gold is a metal. It's a Roman metal. O is oxygen. We know that would be oxide when it's a negative ion. So I uncrisscross. Is oxygen really -2 according to the periodic table? Yes, so that means gold must really be 3. Now I snuck in the Roman metals. Should have put this slide first, but this is describing the Roman metals. Some elements do not have a set charge. Roman numerals tell us the charge, and they're on your sheet. And those are the ones I call Roman metals. So looking at this, this would be all of these guys. I'll cheat here a little bit. Are Roman metals. So it's a metal. I look to make sure it's Roman. Uncrisscrossed. Is chloride really -1 on the periodic table? Yes. So it's iron 3 chloride. The reason why I check to make sure that it's really -1 is if it should be -2, then I have to double the charges when I go through that. Mn. Ooh, manganese. Uncrisscrossing gives me manganese 2. Nitrogen. Ooh, make that sound, end in "ide" and sound good. Nitide, nide, nitride. Oh. Theo. Iron. Roman. Boop, boop. Is oxygen really -1? No. Oxygen is really -2. So instead of this being iron 1 oxide, it has to have twice that charge to cancel, iron 2. Iron 1 oxide would be Fe2O, which is not what we have here. Iron 2 oxide is not Fe2O2 because we'd need to reduce it. Good. Sn, tin. Roman metal, you betcha. Oxide. Whoop, whoop. Tin 2, This implies that oxygen's -1. And since it's not -1, it's really -2. I have to double it, so it's not tin 2 oxide, it's tin 4, good buddy, oxide. Here we've got chromium again. I'll actually write the word chromium. And it's Roman. Uncrisscross it. And again, notice how I had to use parentheses to show I had two of these because I have two nitrates. I don't have 6 ions or 32 oxygens. I have 2 nitrates. And chromium's charge is +2, and nitrate is -1, so that's fine and dandy. Uh-oh, I think I better pause it because the bell's ringing. Now, you know what? I'll keep going. So as people come in, they'll have to deal with it. Multiple polyatomics. So this hopefully will help with the parentheses. Polyatomic ionic compounds. We're used taken twice or taken 3 times. So if I had something in parentheses 2, it'd be taken twice, parentheses 3, taken 3 times. Don't change your polyatomic ions like your hand. Yay. Lead-2 acetate. Lead-2 is Pb +2. Acetate, C2H3O2 negative. Crisscross makes you want to jump. Pb1, C2H3O22, no. O4, no. Oh, 2 acetates. Iron 3, Fe +3. Oxalate, C2O4 -2. I'm sure you have that one memorized already. Fe, crisscross, makes you want to jump. The 2 comes down, the 3 comes down. Fe, C2O4 taken thrice. Silver nitrate, Ag, silver. Is it a Roman metal? It doesn't tell me the charge. Oh no. Silver is always +1. If you remember, we made a big deal out of that. Nitrate, NO3 negative, is AgNO3. Do you notice the nightmare this becomes if you do not know your polyatomic ions? Arg. Go. Why do we crisscross again? Compounds have a net charge of nothing. When do we crisscross again? For ionic compounds. So again, we crisscross to equalize charge. My class is coming in right now, so they're wondering why they can't see on the board what I'm writing. When do we crisscross again? When it's an ionic compound. When is it ionic? When the compound starts with a metal. Let's do some last fun ones. BaSO4. Oh, they really want to see this. I don't have it set up. BaSO4. Ba. Is it a metal? Yes. Is it a Roman metal? No. So I just write barium. What's SO4? Sulfate. NaHCO3. Na. Sodium. HCO3. CO3 is carbonate. HCO3 is hydrogen carbonate. Oh, but I memorized it as bicarbonate. That's fine. It's tomato, it's tomato, it's the same. NH4OH. Ooh, the one positive ion we have. This is not a metal, but it is a polyatomic positive ion, so it's an ionic compound. So it's ammonium hydroxide. I'm feeling very self-conscious as people watch me do this. NH4, and laugh at me. NH4 taken twice, S. So this 2 here freaked me out a little bit, but that just tells me that the crisscross works. So again, it's ammonium. The only time it doesn't start with a metal. And then S is all by itself. I need to make it sound. I need to make it end in -ide and sound good. Ammonium sulfide. There are examples. That's it in under 14 minutes. Woo! Hopefully you're having a great Sunday watching football, unless you, of course, rushed home on a Friday night to watch the podcast. So see you in class, or Saturday, because we all know Saturday is podcast day. Have a good one.